Hello, my name is Rich Howard, owner of Architectural Builder Supply. In this video is to bring you a closer look at the door controls number PS17. This is a power supply is what it is. This is a dual voltage, field selectable 12 or 24 volt. And we're going to go over everything. It's heavy. It weighs about 5.5 pounds with its steel enclosure, its transformer, circuit board, etc. Real nice feature, of course, is having a legend of what everything means on the inside panel. Okay, and that, of course, is buried down in the installation instructions. You're going to get with this a key lock. That's standard. That's nice. You have the ability to either lock that or not. Okay, so now the PS17 is a power supply that will convert line voltage, 115, 110, 120 AC, into two individually protected 12 or 24 volt outputs. So it can do 12 or 24 volts, but it can do two individual outputs. We'll go over that in a moment. Intended for use in applications that are requiring UL 294 compliant access control power supply. That also has a fire alarm control input, meaning its code, of course, that electrified hardware, if receiving a communication, like opening a circuit, will cut the power, operating stuff. This, of course, has that fire alarm input. NEMA 1 enclosure supplied with a keyed cabinet lock and an optional battery backup. We'll talk about that more in a moment. 120, 110, 120 VAC input, 12 or 24 volt, and we'll give you 1.75 amp, and it's field selectable. Let's talk about the field selectability. There is a dip switch here, and it'll be on the installation instructions. You really can't, the camera's not going to focus on it, but it tells us that we are dealing with, it's SW1, and it ships from the factory in the off position, which I believe is going to be 12 volt. So be mindful that it's putting out 12 volts when you get it, and the installation instructions tell you wire it. First thing you do is put your multimeter on there and check the outputs that it's sending out. Filtered and electronically regulated DC output. So it's taking AC in, it's going to give you filtered, regulated DC output. Overcurrent protection on each output circuit as well. Okay. One normally open and one normally closed. Externally triggered by fire alarm relay if desired. Auxiliary DC output circuit not triggered, overcurrent protected. So be mindful, and we'll talk about that in the installation instructions. There is a DC output circuit that is not triggered from the input from the fire alarm. Terminals for fire alarm relay connection. A built-in charging circuit automatically charges backup batteries if they're installed. Powder-coated gray, made in the United States. Nice quality item, absolutely. Now, there is a link below this video to the product information, and that will allow you to review the DCI catalog section where this can be found originally. And I think when that fires up, I think what you're going to discover is that it's probably only referred to there in the book. And it's certainly mentioned there, the PS17. And what's handy about the link to the cut sheet or product information is the fact that you can review the PS17 and its sister products and its accessories. For instance, you can order the PSL17 to receive the optional internal battery backup. And battery backup is pretty common and important to use in the sense that you might need to have an opening where if the power were to go out, you still want the doors to be locked. Obviously, that would be something that you need to take into account when it comes to the fire alarm panel. So having batteries connected to something that needs to cut out by code if there is a fire condition needs to be well thought out, but you very likely could have an opening that's not necessary to have that. For instance, in the building that I work in, there is not a fire panel that is going to unlock, or to release electromagnetic door holders like you'd see in a hospital. So if I ran, let's say, if I ran an electromagnetic lock, and I had that locking the door, and the power went out. Well, naturally, electromagnetic locks are absolutely fail-safe. Power is cut, they're unlocked. I would probably want to have enough battery power, amp hours, installed so that I could bridge the time of last person out of the building until first person comes, or someone is notified that there's a power outage and that you know that you've got 4 amp hours of runtime nominally, or however you do that, however you configure your batteries so that the door is not unlocked. So anyway, your battery, you can have batteries for that sort of scenario. There is also the PS17-TD2, which is going to give you a time delay system for special locking arrangements, which very likely could give you a scenario that you have a back door to a restaurant or to a store, electronics store. You want to be able to have a delay of 15 or possibly 30 seconds if it's approved before the lock will unlock. So the TD2 would have onboard circuitry that says, okay, you're requesting to exit, great, let's start the countdown, allowing whomever to get to the opening. A real scenario would be an electronics store. You don't want someone being able to, walk off with a box of, whatevers. But a more practical scenario might be where you have assisted living and the personnel on shift at that moment need to be able to get to the door so that the elderly person is not permitted to physically exit the building, because code will permit delayed egress, almost always only 15 seconds, occasionally 30, but that gives the nurse time to get to the opening to avert the problem of unauthorized exit, but still being code compliant for exit. But an input from the fire alarm will cut that time delay, and you're gone, you're out. So that's the TD2. Then you see below there all the battery options that are there, and you'll notice the AH, the amp hour, and that gets into what I was talking about earlier in terms of under the load of what you are going to run to it, how many nominal amp hours you would have to expect the power supply to continue to work. If it's 5 amp hours, I do not believe for a moment that it will actually hold or run for 5 hours. And I would think that an expert would probably tell you to use a factor of maybe 1.25 or something in that range. But I can tell you that the experts tell me to calculate 1.5 when it comes to calculating the size of the power supply you need. So if you think you're going to run an amp or just heavy on an amp and an eighth, 1.5 puts you at an amp and a half or an amp and 5/8. Here comes your 1 3/4 amp power supply. There's a table down below that tells you how many devices you can run based on what voltage you're pumping out of the power supply. The other stuff that's there talks to you about other power supplies as well. The PSL30, that's going to be a bigger power supply that will give you more amps, is the bottom line. Okay. Now let's move to the installation instructions. and simple and straightforward. Let's dive into it. The PS17 is a power supply. We've talked about that. It's UL 294 compliant. It's going to give you 1 3/4 continuous supply at 12 or 24 volt. I'm not really sure how that works because I understand that as the voltage goes up, the amps go down. I would expect there to be not 1 3/4 amp for either power supply. But nonetheless, that's the published data. Filtered and electronically regulated output. You've got a Form C, single pole double throw, 1 amp at 28 volt DC, auxiliary relay output. An AC fail output relay, another Form C, 1 amp at 28 VDC. The enclosure is 8.5 by 7.5 by 3.5. 8.5, 7.5, 3.5. I'd say that'd be pretty close. Power supply output, you're going to switch that dip switch to either 12 or 24 volt. It is set in the off position right now. I believe it's in the off position. You're going to want to test that before you do anything. It's definitely in the off position. SW1 is in the off position. So it's at 24 volt, which would make sense to me. I think that's a bit more common. Now, installation instructions. Mount the unit in the correct location, probably up above a ceiling, near the doorway as much as possible. Connect your your input line voltage to the black and white flying leads to the transformer. Here they are, going to your transformer. Then they're going to talk about your ground wire. It's here as well. Use 18 gauge for all power supply connections. 22, 20, or 18 gauge for power limited circuits, like card readers. Keep power limited wiring separate from non-power limited wiring. Minimum 1/4 inch spacing must be provided. Open SW1 for 12 volt, close it for 24 volt. Measure output voltage before connecting. Power it up, get your multimeter, get in there and test everything, what you're about to wire, to be sure of what's happening. You want to make sure what you have and what you require to power it before going live. Jumper TRG1 and TRG2 unless continuity is provided through a fire alarm circuit as shown on page 3. TRG1, TRG2 has to be jumpered if you do not have an input from a fire alarm. Okay, that will be a normally open sort of connection. Step 6, connect appropriate signaling notification devices for AC fail supervisory outputs. Annunciator is what I'm thinking there. Normally close, normally open. For access control device and fire alarm interface connections, refer to the desired applications diagrams. The rest of the installation instructions, with the exception of the terminal identification, give you wiring diagrams. This is what you're probably wiring. And that's really nice because it'll allow even a novice, like me, admittedly, to better grasp exactly what's happening. So TRG1 and TRG2. These input terminals are designed to connect to the closed, common, and normally open terminals of an access controller fire alarm relay. Your fire alarm contractor is going to bring that to this, is how that would work, that I understand. Otherwise, they must be jumpered. No fire alarm input, TRG1 and 2, jumper those. Jumper means a small piece of wire, connect the two of them, you're in good shape. Otherwise, you're not going to get power out of a primary portion of the, of the power supply. If you've wired it and it doesn't work, you may have forgotten your jumper. The terminals control, lock, positive, and strike positive. Lock and strike positive. Sorry. Okay. As well as the PS17 output relay contacts, normally open, normally close. So the input from the fire alarm panel, or the fact that you've jumpered them, is controlling lock positive, strike positive. as well as the PS17 output relay contacts. Normally open, normally closed, and common up here at the top next to your TRG. Okay. Lock positive. This terminal provides DC output voltage when the TRG 1 and 2 are shorted and are typically used to power electromagnetic locks. Absolutely. Two locks may be connected in parallel on the lock positive and the common. Obviously, you're checking to make sure that the amperage requirement is within the capabilities of the power supply. Strike positive. This terminal provides DC output voltage when the two fire alarm inputs are unshorted and are typically used to power electric strikes. Then you've got the normally closed, normally open, and common isolated dry form C contacts. Shorting TRG1 and TRG together causes these contacts to switch from normally open or closed. Or vice versa. They're typically used for controlling multiple power supplies with a fire alarm tie-in, figure 4 and 5 on page 3. So you can have a tie-in, a fire alarm going to a power supply, which will then go to the other power supply, and then putting them in series is how that could work. You could turn off a run of power supplies by that fire alarm. Aux positive, continuous positive DC power output voltage. It's not affected by TRG1 or 2. Maybe a keypad. You know, whether that's powered or not powered, I'm not sure. I would say is not a problem. You've got your common spare wiring terminal used for fire alarm tie-in application, FACP. Then you've got your battery, your battery connections here. Oh, sorry, here. Sorry, let's get those out of the way. Battery positive and minus. Okay. Page 3 is going to show us some typical wiring diagrams where figure 1 is a maglock or a door strike. You have your aux, which is not going to be affected by the TRG 1 or 2 condition. That'll get power. You'll be able to operate the strike or the maglock. Normally open. Okay. TRG 1 and 2 can run through your fire panel or an access control feature. There might be something outside of the electrified hardware that's happening, a system that might be computer-based that will allow you to control the opening via a smartphone, whatever that system is doing. Typical figure 2, typical dual maglock with fire alarm input. That's pretty simple and straightforward. You've got access control, being able to open and close that circuit so you can control it remotely. You've got the fire alarm input, which will cut all of that. Figure 3, same scenario, just with a single lock. But this time, you're using it on the aux positive, negative, and the fire alarm input, the FACP. Okay, that would certainly work. Figure 4, latching fire alarm tie-in with manual reset. Sure, a manual reset could be a key switch. A key switch, you're talking about a maintained sort of key switch. If you obviously lose power, you're going to have to reset that. A manual reset would be required. So you have a maglock. You've got access control, let's say out in the cloud. You've got a maglock. That's powered. You have a fire alarm input. So that will cut the power. Your access control can handle turn on and off. But in the event of a fire alarm condition, you have the requirement to manually reset and close and allow that mini system to work again. Then figure 5 shows how you can have multiple PS17s off of a single fire alarm input. And that's everything. I am not an expert of electrified hardware, and hopefully I've not said anything incorrect in this video, but I know enough to be able to wire this material and even take it a couple of steps further. A PS17 would be really great for using something like, I have the desire to have a timer that I can set days of the week. And at quitting time, I can have my door closed and my electromagnetic lock is going to come on. And that can be controlled by a door switch that basically says, door's closed, turn on the mag lock. Timer is after 5 o'clock on a Tuesday. In the event that the power goes out, I can have a continuous running fail secure deadbolt. So as the power is on, my electromag is locked, securing the door. Power goes out, my fail secure electric deadbolt will fire into the opening. I'm going to need to be able to either restore power to get in or operate that electric deadbolt by a key switch, key control to be able to do that. I could add batteries to all that to make it work. Not that I don't think I would really need to, because I've got my fail secure electric deadbolt working in the opposite, but you need that door switch if you want to tell it when to activate. Probably put a timer on the system as well, so that when the door goes into its closing cycle, you can give it 20 seconds or so to get the door into the closed position before the have the door into the closed position when the door switch knows that it's closed, so that you can re-energize. I think that would work real well. The last page, let's see here now. And that, forgive me, on page 2 gives us an idea of the layout of everything that's here, and we've discussed all of it. You've got your LEDs. You have a red LED if you've got DC power, green if it's AC. Normal function is on both of them, off, and you can see off on the red and on the green, no DC output. System off would be both of them are turned off. Okay. Finally, there's a link below this video to the manufacturer's page where you can pull up not only all of the DCI products that we sell, but also a link to the manufacturer's website, as well as a link to the full product catalog. Any questions on the DCI, this is their power supply, PS17, or any other DCI product, please feel free to reach out to us. And thank you.